I wanted to review with you exponential expressions briefly, just so you can have this review. In the example 3 to the 4th, 3 is called the base, or it's the factor that will be multiplied over and over and over again repeatedly. And 4 is the exponent, or the number that tells the base how many times to multiply itself. So if you had to solve 3 to the 4th power, that would mean 3 times 3 times 3 times 3. 3 times 3, so you would do 3 times 3, you would get 9. Then you would do 9 times 3. 9 times 3 is 27. And then you would do 27 times that 3 and get 81. Not 3 times 4. You don't multiply the base times the exponent. That's incorrect to do. Remember, this exponent tells how many times to write this base, or how many times to multiply this base. So 3 times 4 is not the correct way to solve 3 to the 4th power. Also, not counting by 3. So for example, I wouldn't say 3, 6, 9, 12. That would be incorrect to do as well. Remember, the base is written however many times the exponents specify, and you have to multiply the base that many times. Laws of exponents was something else that we studied. And with the laws of exponent, we learned that any number that doesn't have an exponent on it has a understood 1 as the exponent. And any number to the first power is itself. So x to the first power would be x. 6 to the first power would just be 6. Because any number that has an exponent of 1 is just itself. Any number to the 0 power is 1. So in the example I gave in class, I told you to go home and ask your parents for $1 million to the 0 power. And they probably would say, well, I don't have that much money. And you can say, well, I'm just asking for $1. So remember, anything to the 0 power is 1. Or like here, 7 to the 0 power is 1. It doesn't matter what the base is. If it's to the 0 power, it's going to be 1. The answer is going to be 1. The next law that we learned about was MLB, or multiplying like bases. If you think about multiplying, you should realize that multiplying is nothing but repeated addition. And since when you multiply and it's nothing but repeated addition, when you multiply like bases, you're just going to be adding the exponents together. So x to the m times x to the n is just x to the m plus n. I will be adding these exponents, the m and the n. So in this example they gave you, 2 to the second power, x to the second power, or x squared, times x to the third power, or x cubed, would be nothing but x to the 2 plus 3, because x squared means I would have 2 x's, and x cubed mean I would have 3. And if I multiply x times x, that's the 2 x's, and then x times x times x, that's the other 3, I would have 5 x's that I would be multiplying. So my answer is x to the 5th. Now, just like with multiplication being repeated addition, division is nothing but repeated subtraction. So when you are dividing, you are repeatedly subtracting. You actually subtract and then bring down as a part of division. So when you are dividing like bases, you would subtract the exponents. So x to the m divided by x to the n is going to be x to the m minus n. So I would just subtract the m and the n, which are the exponents. In this example, x to the 6 divided by x squared would just be x to the 6 minus 2, or x to the 4th. And remember, when we did this, we said, okay, we're going to match x at the top with an x at the bottom. That would make a whole. Divide an x at the top by x at the bottom. That makes a whole. Divide an x at the top with the x at the bottom. That will make a whole. Until one of the x values, until one of the amount of x's runs out. And then you'll see how many x's you have left. So basically, we're subtracting x's from the top and bottom to see how many will be remaining. So x to the 6 divided by x squared would be x to the 6 minus 2, which would be x to the 4th. Now, the last law we learned about was raising a power to a power. When you raise a power to a power, like in this example, x to the m raised to the n, you will be multiplying those two exponents together. And this is how that works. If I had x squared in parentheses, And then I want to do that to the third power. Remember, this exponent is going to tell me how many times to do what's in parentheses. This exponent is going to tell me how many of these to write anyway, how many of these to multiply. So since x squared means 2x's, this exponent is telling me how many times to write 2x's, because x squared is nothing but 2x's, x times x. So this 3 outside the set of parentheses tells me how many x squares that I need to write. So I would have x squared times x squared times x squared. And if you think back up to this law, that would be MLB, where I would be multiplying in like bases, so I would be able to add the exponents. Well, remember, multiplication is nothing but repeated addition. So if I add x squared plus x squared, if I multiply x squared times x squared times x squared, I would add 2 plus 2 plus 2. And a shorter way to do 2 plus 2 plus 2 would be just to do 2 times 3, which is what this is. So x squared cubed would be x to the 6th power, because I'm raising a power to a power. So I would just multiply my exponents.